So let's go ahead and move forward in the agenda to our first panel, if you will. Today we will hear about the 2021 Western drought. What are our current conditions? We will then set the stage to understand how we got here, and then hear about sector and community-based perspectives on cascading drought impacts and needed changes. We will close out with an analysis of the impact of drought on agriculture, local economies, public health, and crime across the Western United States. The first panel in today's forum will be focused on drought conditions and forecasts and the seasonal fire outlook. We will first hear from a group of experts who will provide us with current drought and fire conditions in the Southwest. Following the presentations, there will be a few minutes for Q&As. Please feel free to type your question into the questions box as you would like it to be read. Include your name and affiliation. We will not have time to answer all questions, but we'll select a few and read them for the panelists to answer. So with that, I am grateful to be able to introduce our speakers for this first panel. Richard Heim is a U.S. Drought Monitor author and a meteorologist in the climate monitoring section of NOAA's National Centers for Environmental Information. Dave Dewitt is the director of NOAA's Climate Prediction Center in NOAA's National Weather Service. And Jim Wallman is from the Department of the Interior's Bureau of Land Management. I will first turn it over to Richard Heim. Richard?
Good morning, everyone. I'm glad to be here. I will be talking about the current conditions and historical perspective of the drought in the West. I have a lot of slides, so some of these I will be going through fairly quickly. The current conditions, based upon the September 14, the latest U.S. Drought Monitor for the Western U.S., shows about 89% of the region in drought. That's D1 to D4, moderate drought to exceptional drought, with more than half, 53%, in extreme to exceptional drought, the two worst categories. And based upon the DEWS regions, 100% of the California Nevada DEWS is in drought, 81% the Intermountain West DEWS in drought, 94% of the Pacific Northwest, and 65% of the Missouri River Basin DEWS. Next slide, please. There have been a number of drought impacts resulting from the drought that we've been having this year and last year, and really over many years. They include agricultural impacts, economic, ecosystems, water resources impacts, low stream flows, elevated fire danger, recreation. They're almost endless, and here are some sample pictures of what some of these impacts look like. I won't dwell on them in this talk, since we'll be talking about this kind of stuff later in the workshop. Next slide, please. Okay, the bullets here I'll be talking about in another slide, but the main thing I wanted to emphasize here is that the drought that has been developed over the last 2 years is essentially a result of lack of precipitation. The summer monsoon in 2019 was pretty weak. The following winter, 2019-2020 winter, also not very much precipitation. The next summer, which would be last summer, 2020, the summer monsoon completely failed. The following winter, which was last winter, 2020 to 2021, we really had a failure of the winter precipitation. So 2 summer monsoon seasons, 2 winter wet seasons below normal precipitation, well below normal precipitation. This summer, the summer monsoon returned to the Southwest, but gosh, you're looking at years and years of below normal precipitation. One wet summer monsoon isn't really going to make up for this deficit. And also it was unusually dry in the Pacific Northwest. Next slide. So how dry was it? We look at the statewide average temperature precipitation values for these various time periods. For the last 12 months through June, this is before this summer's monsoon kicked in, the 12-month precipitation for July 2020 through June 2021 was record dry. Record dry 12 months for California, Nevada, Utah, Arizona. The 18 months from January 2020 to June 2021, record dry for Nevada, Utah, Arizona, third driest California, Colorado. The last 24 months, July 2019 through June 2021, still record dry for Nevada and Utah, second driest for California, fourth driest Colorado, sixth driest Arizona, seventh driest New Mexico. So we're looking at some really dry, record dry conditions. Next slide. Okay, let's incorporate this summer's monsoon precipitation. Statewide precipitation ranks as of August 2021 through the end of last month. Still, the last 12 months, September 2020 through August 2021, still record dry, California, still second driest in Nevada, and a little bit better in Utah, New Mexico, Colorado, Arizona, but still in the driest third. The last 18 months, March 2020 to August 2021, still second driest Nevada and Utah, fourth driest California, Colorado, and the 24 months, September 2019 to August 2021, still second driest California, still second driest in Utah, even with the abundant precip that they've been getting the past 3 months, third driest Nevada, fourth driest Colorado. Next slide, please. Okay, let's look at temperature. Precip is only one half of the drought equation. The drought is basically an imbalance between water supply and water demand. Precipitation is water supply, low precip, drought. Evapotranspiration is water demand side. Temperature is an important factor in that. Higher temperatures, more demand, more drought, or exacerbating drought. And we've had warmer than normal conditions during this period, the last 2 years especially. Record-breaking heat accompanied the Southwest monsoon failure in 2020, and record heat occurred in the Pacific Northwest in early summer 2021 and across much of the West for June to August 2021. And the excessive heat has led to excessive evapotranspiration as well. Next slide. Okay, drier than normal and warmer than normal conditions during the last 2 winters resulted in poor winter and spring mountain snowpack and early melt. And of course, the mountain snowpack is an important factor in replenishing reservoirs and providing the water supply during spring and summer dry season. And the mountain snowpack as of April 1, 2019, 2 years ago, was pretty good because we had an El Nino. But then the 2020 April 1 snow water equivalent mountain snowpack was near to below normal, and even worse this past April 1. Next slide, please. And of course, this has been reflected in reservoir levels. Increased water demand, lack of precipitation, and lack of spring mountain snowmelt for the last 2 years has depleted the reservoirs. 2 years ago, September 1, 2019, only 2 states had below average reservoir levels averaged across the state. That increased to 6 by September 1, 2020, and now only 2 of the Western states have a near to above normal, really near normal reservoir levels statewide as of September 1, 2021, just a few weeks ago. So this has been a serious situation. The drought, even though we've been having some good summer monsoon precip, it hasn't done a whole lot to replenish these reservoirs. Next slide.
Richard, pardon the interruption, you have 3 minutes left.
I have 3 minutes, oh my. Soil moisture, a lot of indicators. I'll only be talking about the USDA CASMA. And next slide. The soil moisture has been decreasing, has been really dry. Topsoil moisture during this entire period, especially in the Southwest corner states. Next slide. And this shows how the drought has expanded over the last 2 years, starting in the Southwest, expanding across the West with the dry summer monsoons and dry winters. Next slide. The percent area of the West reached a record in 2021 90.3% in D1 to D4 this past July 27 beats the record in 2003, and D3 to D4 59.5%. July 20 beats the record from 2002. This is the U.S. Drought Monitor 20-year record. Next slide. The VHI from NESDIS star for the last 40 years shows much of the last 20 years in drought. Next slide. The Palmer Drought Index goes back to 1900. We also set a record for the percent area of the West, shown in the graphic in the upper right, as the region. 99% of this region at the end of June was in moderate to extreme drought. That beat the record from 1934. Next slide. Temperature and precipitation. We had the driest April through June this year. I'm sorry, the warmest April through June this year, and the second driest averaged across the West. July 2019 to June 2021 was the driest such 24-month period on record west-wide, and the fifth warmest. Next. And this past summer, the warmest June to August on record, averaged across the West. Next slide. The SPEI integrates temperature and precipitation, and the combination of temperature and precip extremes has resulted in record to near record low SPEI values at various timescales over the last 20 years. And this is the 12-month SPEI. If you look at the next slide, if you integrate this over the last 6 years, we have the cumulative effect of the current these conditions repeated year after year over the last 20 years does not bode well for the West, especially California, Nevada, and Arizona, where it's perpetual drought based upon this SPEI for over a 6-year period, going back the last 10 to 20 years. Next slide. So the conclusions: the current drought conditions in the Southwest and West-wide have arisen from excessive record dryness and heat of the last 2 years, especially the failure of the summer monsoon and winter precipitation. The current drought is occurring within a broader context of a 2-decade-long drought episode in the West, and temperature and precipitation trends over the last 20 to 40 years indicate a changing hydrology, which makes the region more prone to drought. And that concludes this presentation. Thank you.
Thank you, Richard. Great presentation. Not a lot of great news there, though. So let's go ahead and before I move on and to hear from Dave Dewitt with the climate outlook, let me just remind folks that again that we are going to have about a 10-minute opportunity at the end of these presentations to take some questions. So a reminder again, if you have a question, please put it in the questions box along with your name and your affiliation, and then we can choose the questions to read out. So Dave Dewitt, you are up next.
Great, thanks, Viva. Can you hear me?
Yes, we can. We can't see your camera. I don't know if you want to turn your camera on or not. It's up to you, but just we can hear you loud and clear.
Okay, great. Yeah, no camera due to the flood damage, unfortunately, in the house. My apologies on that. So I'm going to briefly discuss the major climate forcings for the upcoming fall and winter and the associated outlooks from the National Weather Service Climate Prediction Center for drought, temperature, and precipitation. Next, I will discuss major science gaps in our ability to predict the onset and termination of drought. And finally, I will briefly describe a collaborative project between the Climate Prediction Center and the National Integrated Drought Information System, NIDIS, to improve our existing drought outlooks. Next slide. So the major short-term climate driver that will impact southwestern drought this fall and winter is La Nina. La Nina conditions are indicated by below normal sea surface temperatures in the central and eastern tropical Pacific, and is typically associated with an enhanced probability for below normal precipitation for much of the Southwest during the fall and winter seasons. Next slide. So the Climate Prediction Center official outlook for this fall calls for an enhanced probability of above normal temperature and below normal precipitation for most of the Southwest US. As Richard mentioned, warmer temperatures generally lead to enhanced evaporation. So both the temperature and precipitation outlooks are favoring enhancement, sustainment, or development of drought for the Southwest this fall. Next slide. So the CPC official outlook for winter tells a very similar story to that for the fall, with an enhanced likelihood for above normal temperature and for below normal precipitation for much of the Southwest, again favoring sustainment, development, or intensification of the drought currently existing in the Southwest US. Next slide. So the US seasonal drought outlook underscores the point that we expect drought to continue, intensify, or develop over most of the Southwest US this fall into winter. Next slide, yep. So I would like to speak about some science gaps in our ability to predict drought. So in this case, I am speaking to the onset of flash drought, and as an example, I'm going to use the case of the 2017 flash drought that occurred in the Northern Plains. So this drought onset, you can see this red ellipse here, over about a 60-day period, and state-of-the-art models were only able to predict the onset of this drought at about 1 to 2 weeks lead. That's all models around the world, right? So that's the US model, the European model, the UK Met, Canadian. Everybody's in the same boat when it comes to inability to predict subseasonal to seasonal precipitation on timescales beyond about 2 weeks. I do want to comment that Andy Hole, who I believe is a panelist on this, who I know is a panelist on in this meeting, and his colleagues conducted a beautiful study for NIDIS that looked at the predictability and predictive skill that was manifest for this event. And I strongly encourage people to read that report if you haven't seen it already. Next slide. So next, I'm going to speak about the rapid amelioration of the multi-year severe drought in California that occurred in very early 2017. Again, look at this blue ellipse. This amelioration of a very severe drought occurred over about a 60-day period and was only forecast at a lead of up to about 2 weeks. And I should note that this occurred despite La Nina conditions, which, as we've previously discussed, generally favors below normal precipitation for most of California. I should also note that this year's monsoon, this year's Southwest summer monsoon, which Richard mentioned, has been at normal or above normal, was similarly only predicted accurately at about a 2-week lead. So longer term forecasts from the state-of-the-art models indicated mostly below normal precipitation for the Southwest monsoon. We know that has turned out, fortunately, to not be the case. Again, underscoring this fact that the state-of-the-art models are not able to capture transitions from very wet conditions to very dry, or vice versa, beyond about a 2-week lead. Next slide. So the final topic I want to cover is an exciting collaboration between NIDIS and CPC that will lead to an objective probabilistic drought outlook. Key features of this probabilistic drought outlook will include co-development with stakeholders to ensure that the outlook will be both useful and usable for them. It's also going to have a very long, consistent set of historical predictions that will allow establishment of skill and confidence levels that will help to inform stakeholder decisions, i.e. does it meet their risk tolerance for skill and confidence. But I also want to emphasize that, as I mentioned earlier, in order to get maximum value from tools such as this, we need to continue to improve the skill of our subseasonal to seasonal precipitation forecasts. Next slide. So in closing, I want to emphasize again that given the strong likelihood of La Nina conditions and a warm temperature trend this fall, the drought in the Southwest is likely to persist, expand, and intensify. And that will continue, those conditions will continue into winter. Transition to a wetter pattern would only be forecastable accurately at approximately 2-week lead, and there's no indication at this time that that is going to happen. This limited predictability for precipitation on this timescale is truly a grand challenge that the science community, I hope, embraces so that we can try to do a better job in informing stakeholders for their water resources needs. And in order to do that, we will require sufficient sustained investment targeting some extremely challenging science issues. Finally, CPC and NIDIS are collaborating to produce probabilistic drought outlooks that will be co-developed with stakeholders. Thank you very much for your time.
Thanks so much, Dave. I appreciate the remarks and the presentation. Okay, we're going to go ahead and move on to next hear from Jim Wallman about fire conditions. Jim?
All right, thank you, Viva. Well, we'll go ahead and just talk about the fall fire outlook, but at first I'm going to discuss the current situation across the West with our fire season. Next slide, please. Right now, we are just dropped yesterday to preparedness level 4 nationally, which is on a scale of 1 to 5. Northern California area is still at a preparedness level 5. The preparedness level is based on current fire activity, forecast weather, and also the amount of resources available. Generally, when we were at a preparedness level 5, we are tapped out of resources nationally and have to look into the military or international agreements to supplement our resources in the States. This year, we spent our longest period at preparedness level 5 since 1990, when records began being kept here at the National Interagency Fire Center from July 14th to September 20th. We are currently at 90 days at preparedness level 4 or higher, which is also the longest ever since 1990. Currently, there are 21 type 1 and 2 incident management teams deployed across the Western United States. Next slide, please. While we look at the background with the drought, it's kind of at the transition between weather and climate, where short-term weather events can impact the fire season, especially when well-timed. One example is the recent precipitation event last weekend over much of the Northwest, Northern California, into Idaho and Montana. While activity was still ongoing across the Northwest and Northern California, 3 to 5 inches of rain on some of the fires in Western Oregon, west of the Cascades, and up to an inch or 2 inches of rain in Northwest California has significantly slowed activity there. However, in the Sierra, especially on the east side where portions of the Dixie Fire and Caldor Fire are burning, they did not receive as much precipitation. One other area that is of note here is across central Idaho into southwest Montana, which did not receive as much rainfall with this event. And if we go to the next slide, it can show the energy release component. So the energy release component there, and this is on a percentile based on historical values. Anything generally below 58% is shown in the green, and anything below 78% in the lighter green. And so these values here are showing that it still remains dry, quite dry across central Idaho into southwest Montana, where we still have a couple of large fires burning, as well as portions of Southern California, especially the Southern Sierra into central Nevada, where it remains very dry. However, if you were to look down into the Southwest, Arizona, New Mexico, and Utah, as a result of the robust monsoon this year, that the energy release components, or the amount of fuel available to burn actively, is closer to background values, if not below normal for the time of year. Next slide. So going through and looking at our significant fire potential outlooks, these are issued monthly, forecasting above or below normal significant fire potential for the next 4 months. So what we have just done, we completed it last month, is looking for the rest of the year from September through December. We are about to do our discussions here in a couple days for the next outlook, which will be from October through January. It combines the current situation with forecast weather and climate. So we use the Climate Prediction Center outlooks. They're also invited on our calls, and we have discussion. And we also go into a more detailed discussion of the total fire environment. These are really a great planning resource for the fire committee, where severity requests and resource allocation extensions of teams or resources are used, and these are a really good planning tool. So for the next 4 months, we go to the next slide, at least for the rest of September, this has changed somewhat based on the recent precipitation, but at the beginning of the month, we were looking at above normal significant fire potential for much of the West, and also in portions of the lee sides of Hawaii where it has been abnormally dry. And also with the drought in northern Minnesota, we've had large fires there this summer. One of those fires, the Greenwood fire, burned over 26,000 acres last month. So that was what we're looking at, although the conditions now for especially the Northwest and Washington, Oregon with the recent precipitation event are probably going back to normal as we head into next month. And if we go to the next slide, we are looking at part of this is function of the time of year, looking at below, going back to near normal significant fire potential for the Northwest and Northern Rockies as they generally come out of fire season, but continue to be above normal for Northern California and then portions of Wyoming into Northwest Colorado where it is still dry. Also the lee side slopes of Hawaii. There also is potential for dryness along the East Coast as we head into fall, although the timing of any longer dry periods and whether they coincide with fall leaf drop will really dictate the fire potential. If we go to the next slide for November, really our above normal potential for areas is really going to be confined to portions of the Southeast and Mid-Atlantic and Northern California, especially Northern California due to the long-term drought and until the first significant precipitation events arrive for the winter season. So that's what we're looking at. And again, like the Southeast will be mitigated potentially, depending on when the drier periods occur and whether they coincide with the fall leaf drop. And then next slide. For December, we are just forecasting a near normal fire potential at this time of year. Generally, most of the country at this time is generally out of fire season, so we're not looking for anything above normal potential. But there are a couple areas that we will continue to monitor, especially Southern California into December with the La Nina. And if it continues to remain dry, any significant Santa Ana events could elevate the potential there. Also, any troughs moving through the Southwest into the Southern Plains, we could have brief periods of above normal potential with strong winds coinciding with any dry periods there. So last slide. If you go to the next slide, just to summarize, really we've had a really significant activity observed for a long duration this summer, longer than we've ever observed in the last 30 years. The recent rainfall event has significantly slowed the season for the Northwest quarter of the United States, with higher than normal potential continuing for portions of the West, mainly in the Northern California, Wyoming, and Northwest Colorado into November. There is also potential for the higher than normal potential in the Southeast, but again, depending on any dryness coinciding with the fall leaf drop. And then as we head into winter, we also kind of monitor, although it's more the focus of the National Weather Service at the local offices, potential for any debris flows on the West Coast with any landfalling atmospheric rivers during the wet season. And thank you.
Thanks so much, Jim. Appreciate the presentation. So this is, we actually are a little bit ahead of schedule, which is great because it allows us to have a little bit more time with the panelists. So I'll invite the panelists, Richard, Heim, actually, to join us on, turn your camera on, and we can start the Q&A session. I wanted to remind folks, if you have a question that you'd like to ask, go ahead and type it into the chat box. I do have a couple of questions that have come in. I also wanted to give Richard a chance because I had to hurry you along because I was thinking that we were going to be at time, but we have a few extra minutes. So I'm offering you the opportunity, if you wanted to elaborate on anything in your presentation that you think if you'd had a few minutes more, you could have covered a little bit more.
Yeah, I noticed on the slide that had the temperature time series and the precipitation time series west-wide, I skipped over the two left-hand side slides showing the 12-month precipitation and 12-month temperature over the last 127 years. The last 20 years precipitation 12-month values have been drier than the long-term average than wet for the west-wide, and the temperature time series for the last 40 years has been showing a marked increasing trend in heat. And that I wanted to mention will be a problem for evapotranspiration, exacerbating drought when it happens. And it just seems to be getting worse and worse. Just that June to August summer 2021 point on that summer temperature graph, it's just it's a full degree warmer than the previous record summer temperature west-wide. So it's kind of just blows me away when I look at those time series that we have some issues in the West when it comes to drought, and the data just show that it isn't going to get any better. I also wanted to mention the VHI, Vegetation Health Index time series that I showed. There was a 2 time series for each state, one for all of the land and the other for the agricultural parts of the land in each state. Those time series for the last 40 years from the NOAA NESDIS star people show that the last 20 years have been predominantly drought prone in these 6 states. And the 1980s and 90s had some droughts. The late 80s, early 90s drought in California, and I think it was Arizona, they show up very well in those graphs as well. And the VHI is, of course, a satellite-borne indicator that measures vegetative health. So it's what we've got on these data. These time series are very consistent across platforms, across types of data. It's just amazing.
Thanks for the elaboration. I think it definitely corresponds with this dialogue that we're going to be having for the next 4 days. Let me go ahead and tackle a few of these questions here. We had one question for Dave Dewitt. The question is, can you elaborate on the grand challenge in predicting subseasonal to seasonal precipitation? What are some of the biggest barriers to incremental improvement in the predictive skill in this area?
Sure, I'm happy to address that, Viva. So the primary prediction tool that we use are these very complicated ocean atmosphere coupled models, which do a lot of things very, very well. One of the things they don't do particularly well at is tropical precipitation, and the tropics, it turns out, drive a large part of mid-latitude variability, essentially where we live. And so you can look back 20 or 30 years, and there are errors that existed when we first started to develop this technology that are still present at about the same magnitude as they were at that time. And perhaps more importantly, the size of the error is the same as the size of the signal, if not bigger. And so better understanding the interaction between the boundary layer in both the atmosphere and the ocean and their interaction and deep convection is a really thorny problem that we have not spent a lot of time, effort, and energy addressing, kind of punting that forward as a difficult problem. I think a lot of people believe if we can make progress on that, that would be beneficial for many things, and certainly with respect to precipitation forecasting over the Southwest U.S. Another key area is land-atmosphere interaction. These models require a lot of computing to accurately capture representations of land and how that interacts, with the soil moisture and the vegetation cover with the atmosphere. And that's another area where we really, and again, the models do a lot of things great. In these areas, if we had improved investment, we could hopefully improve the physical representation, and that would improve, in turn, downstream our precipitation forecasts on subseasonal to seasonal timescales. So thanks for the opportunity.
Sure, and thank you, Dave. Let me ask, I guess, somewhat of a follow-up question, or it's somewhat related. This is a question from one of the media outlets on the line. What science is needed to I'm sorry, I just lost my, what science is needed to improve our ability to predict the transitions in drought conditions? So I think that question could be answered by you as well as potentially Richard as well. So yes, Dave, go ahead.
Yeah, I mean, so from my perspective, again, that really is largely going to be tied to our ability to predict this tropical variability that will influence the jet stream and its contraction and expansion, as well as the land-atmosphere interaction. So it's different. It's different seasonally, right? So western precipitation over California in the winter, that's snow that's associated with contraction and expansion of the jet. Northern plains, southern plains, southwest precipitation in the summer, that's really related to land-atmosphere interaction. There certainly is a forcing component associated with the tropics, but you also need to get that land-atmosphere interaction correct. So it depends on the season, and it depends upon the region.
Richard, did you want to add any insight?
Yeah, I think Dave covered a lot of the aspects that forecasters look at, with the tropics being an important driver, the jet stream, the mid-latitude circulation being an important factor. One thing that I would like to, that I've been thinking about for decades, since I read a paper by Kaunecke back in college in the 1970s, is what effect does changing the atmospheric composition, the greenhouse warming, and changing the heat balance hemispherically, the latitudinal North Pole cold, equator warm temperature gradient, what effect does that have on the jet stream, its positioning, the amplitude of the ridges troughs, the mean latitudinal location of the jet stream seasonally? That is, I think, is an important factor in precipitation, in heat waves beneath ridges, and so on. But there's also another thing that I remember reading, gosh, decades ago, I think a paper by Lorenz concerning transitive, intransitive, and almost intransitive states of the circulation, where the jet stream can be set up in certain wave patterns and very quickly in atmospheric timescales switch from one pattern to another. Those aspects, I think, are things I'd like to see explored more in forecasting and atmospheric research. The jet stream, the nature of it, how is it going to be changing?
Great, thank you, Richard. I didn't want to leave James or Jim out. We do have a question for you. It's not 100% Southwest related, but let me go ahead and ask it. With the Southeast having a wet summer with above average precip, would the risk for wildfire be mitigated somewhat due to the prediction with elevated soil moisture levels heading into the fall season?
It can be an impact. However, the research that was done at our Southern Area Coordination Center in Georgia, what they found is that drier periods that coincide with your the leaves falling off the trees and your fine fuels that end up going on the ground, that they are the drivers of large fires in that area. So while your herbaceous fuels and your live fuels such as grasses, your shrubs will remain green and not contribute to fire, the larger fires in that area are largely determined by your fall leaf drop coinciding with dryness.
Great, thank you. And I think we had one more question that we have time to cover. Two of the presenters, I believe it was Dave and Richard, mentioned La Nina as a climate driver. Are there other drivers that we can look at for drought development or relief in the West?
Dave, you want to take that?
Yeah, sure. So if you look at the major modes of variability on a seasonal time scale, El Nino, La Nina is the strongest by far, right? And so that's why we tend to speak about that. Now, it's not a perfect predictor, obviously. I mean, I gave the case of California, where despite La Nina conditions, very strong flooding, in fact, record flooding. if you go to the shorter time scale, there's another phenomenon called the Madden-Julian oscillation, which is extremely important. And again, it's this fact that variability in the tropics forces the mid-latitudes in several different mechanisms. There are also other wave mechanisms near the tropics that have similar impacts on the mid-latitudes. So yeah, I think that's how I would answer.
Yeah, I think I would add that there are other indicators, other modes that have nice acronyms like PNA, AO, NAO, North Atlantic Oscillation, Arctic Oscillation, North Pacific Oscillation, things, and those are more mid-latitude driven, but their predictability is weaker. Their time scale is not as long as the ENSO is, and I do want to mention that Dr. Namias over from the 1950s into the 70s and 80s focused a lot on mid-latitude drivers, but this was before the big El Nino of 1983 focused attention on the tropics and illuminated how important the tropics were. So that there are other things besides the tropics that drive the circulation. It's really hard to determine and predict the mid-latitude jet circulation, the jet stream, as a predictor, because it both is influenced by oceanic temperature, sea surface temperature anomalies, as well as affects them. There's a two-way interaction there. But whereas the ENSO, the La Nina, El Nino are much more solid, the science is much firmer, they are much better predicted, as well as the MJO. So I think I just leave it at that.
Okay, great. Well, thank you again to our panelists. We appreciate you spending some time with us this morning. Appreciate the foundation that you are starting to lay with us for the rest of this forum.